So good afternoon, everyone, and warm welcome to this reference designation system webinar. It's great to see so many participants joining today to listen our presentation to ISO IEC 81346 series. My name is Arto Sirviö, and I work for CESCO. CESCO stands for Electrotechnical Standardization in Finland, and my role is a group manager. Today we have presenters from Denmark who are very experienced on developing ISO IEC 81346 series and also applying that in practice. So today's program is shown on the screen, and we are now doing the introduction. And then we have a set of presentations. If you have questions, could you kindly write it down, and after the presentation we will take the questions and answers. So the history of designation standards begins on 1970. First, there was IEC standard 60113-2 for item designations or equipment designations. And then it was replaced by IEC 6750, somewhere in early of 80s. And also from Finland perspective, we had a Finnish national standard SFS 4622, based on the IEC 6750. Then Finland joined EU as a member in 1994, and we started using EN standards instead of national standards. And many of the national standards need to be replaced by equivalent European and IEC standard. IEC Technical Committee TC3 started to develop new standard IEC 61346. It was intended to be published as a series, and the new thinking system level designations called reference designations. And this standard aimed to be support lifecycle management on each object of the system. Also, industry, this was response from industry needs to have a system level reference designations. First part was published in 1996. It provides general requirements and rules for system reference designations. Then it followed by part 2, which provide classification and class codes for different kind of objects. During that time, this was quite electrotechnical standard developed by TC3, and it was followed in ISO standard 16952-10 for power plants. Then IEC TC3 and ISO committee TC10 had a discussion to have a joint standard for reference designations, and the work started to develop 81346 series, and somewhere in 2009 and 2010 new standard was published. The first part provided general requirements, and the second part for classification different kind of objects. And this time the reference designation systems was developed for all kind of technical systems, not just the electrotechnical, but also in buildings and machines and airplanes. 2015, ISO TC10 developed 81346 part 10 to replace the old 16952-10 by applying the new rules and new classifications. And this was also for the power plants. Then 2018, ISO TC10 published another part 12, for building systems, different kind of building automation, wall systems, roof systems, and having classification codes for building objects. Then 2019, Part 2 for classification and letter codes was upgraded to edition 2, and 2022 Part 1 was upgraded to edition 2, followed by ISO TC 10 81346-10 upgraded to edition 2. And now we are living in 2025, and we have currently at least 5 new projects on the pipeline. As I said, reference designation system has a background from electrotechnical field. And the well-known use case is from low voltage electrical installation standard based on international IEC 6364-5-51 and equivalent European harmonization document 6364-5-51. These are implemented in Finland as a SFS 6000-5-51 standard, and this part of the low voltage electrical installation define the requirements for drawings and how to document electrical installations in Finland by applying SFS EN 81346 standard. Then some words about part 2 and 1. Part 1 is a dual logo standard. That means that it is jointly developed by 2 committees, one from ISO and one from IEC. The designations 81346-1 IEC means that the maintenance responsibility belongs to IEC committee TC3. This standard is also having a special status called horizontal publication. That means that when IEC and ISO technical committees they develop product standards, and when there's need to be define something or some requirements for identification for system objects, then horizontal publication should be applied when applicable. In the past, before 2020, this special status was called horizontal standard. Nowadays we call it horizontal publications. These standards are also translated in Finnish, and they are available for dual language Finnish and English versions. And something about the maintenance of this series. As I said, it's currently joint development from ISO and IEC, and Technical Committee TC3 has a joint working group 24 for maintenance of IEC 81346 series linked to ISO TC10. So that means that this series can have multiple parts, some parts from maintenance responsibility for ISO committee and some parts for maintenance responsibility for IEC committee. Currently, TC3 work program consists 5 projects. Part 2 is going to be upgraded, edition 3. Then we are going to have new parts. Part 8, it's about the object properties. Part 14 is for manufacturing and processing systems. Part 20 is for vehicle systems. And part 50 for the processes. So that means that currently this standard is very heavy development actions. So there are going to be additional guidance for specific sectors, how to apply reference designation systems in practice. So that was my presentation, and then we move to the next one. Next presentations were Philip and Henrik will provide additional information.
First of all, thank you so much for inviting me and Philip to present 81346 for you today. We've been looking very much forward to this presentation for all of you. Just one slide about our company and what we do. Our company name is Systems Engineering AS, and we do very different projects, from medical devices over big complicated plants, a lot of green energy. We worked for Airbus since 2017. We worked with mechanical devices, electrical devices, machinery, and a lot of stuff that you can see here on the screen. And what do all these companies actually have in common? Well, they believe in 81346 as well as we do, and therefore you are not first movers if you want to move in this direction, but you can be a fast follower. A few words about myself before I hand over the microphone to Philip. My name is Henrik Batsløv. I have a background in high voltage electrical engineering, and I've been using this IEC 81346 standard for the last 30 years of my career. It's a standard that constantly develops. It constantly shows me new faces. It constantly shows me something new I can use it for. So it's not just a steady fixed document. It's actually a very living document that constantly offers you new opportunities. And these are these learnings and these takeaways that we have been looking very much forward to share with you guys today. Besides being an electrical engineer, I'm the managing partner in our company, and I've had the pleasure to have the IEC 1906 award for our contribution to this international standard twice. So with these words, a warm welcome, and over to you, Philip.
Thank you so much, Henrik. I don't have as much experience as Henrik has regarding the 81346. I've only experienced with it for the last 5 years. But that also means that for the vast majority of my professional career, I've been deeply involved with this standard, both from an implementation point of view, where we go out into the industries and see how does this standard actually applies in the real world. But I'm also quite proud to say that I'm the project lead for many of the new initiatives and many of the new parts that Arthur he mentioned before. For example, part 50, part 8, and part 14 as well. So that was a little bit about me. But now to the actual first question of today, where we would like your input to get a little bit of a discussion going, because we would like to know, do you use 81346 today? And here, just as a very simple thing, if you could take up your smartphone, you can scan the QR code here. The answer is anonymous, so don't worry about that. But please, if you would like to participate, you can scan the QR code and just pick the answer which suits you, so to speak. If you don't have a smartphone, you're also welcome to open a tab, and you can go to slido.com and push in these numbers here, 37 10 66 5, and then you should also be able to join. Right, and the great thing is that you can also follow along what people answered. We have 9 people now. That's great. Just give people a moment to finish up here. Yeah, we got 13 people answering. I think that's a good, nice show of hands. 14 people even now. So I think I can say that, yeah, roughly 50% of you are actually, you can say, new in this field and want to know more. And this corresponds very well with also what we see in the industries. There's really a push towards learning more about this standard, because it turns out that it's much more than just a reference destination system, so to speak. It's much more than just a tagging standard. We're also very glad to see that 33% of you already use it today. So we are also strong believers of 346. Maybe today you will learn a little bit about some of the applications, maybe some of the things you can expand upon even more. And for those of you who are partly using it or consider it, maybe this is a way to expand it even more in your organization. But now I want to speak a little bit about why we are so passionate about 81346 and what it has meant to us. And for that, I want to start with a word. It's a word that we have seen quite often, and that is chaos. Because chaos describes quite precisely what we see in larger organizations when people have to collaborate. Every day, engineers, operators, designers face chaos. It's not because they lack intelligence, and it's not because they lack tools. It's because they lack a common language. Hundreds of hours lost, millions in downtime, and endless frustration. We have seen this time and time again, and that's why we have made it our mission to create a common language from chaos to clarity. One of the oldest stories in the world is actually about this tower here, the Tower of Babylon. It's actually about an engineering problem. Humanity decided to embark on the greatest engineering and construction project ever conceived. Everything went well until God introduced a single minor flaw in the world. He made everyone speak a different language. And the result? Chaos and catastrophe. We know the story. We accept it as the truth that when people do not communicate, the project will fail. Then why is it that we expect designers to achieve miracles when they have it just as hard as the people here? This is what most systems look like. This isn't a design fair, it's real life. It's a maze of components, cables, sensors, pumps, valves, software modules, each with its own name, its own format, its own story. And when it breaks, you're left navigating this maze blindfolded. You spend hours trying to figure out what it is, where it came from, and who touched it last. And this isn't actually the whole story. This is just the tip of the iceberg, so to speak. This is just one representation in our design. It's just one viewpoint. We know multiple people with multiple goals track the same items through multiple systems, each serving multiple functions, each with its own format, its own logic, its own language. And when you need to make a decision fast, you're stuck stitching together fragments from 5 different platforms. Decisions made on half the story ends in surprises. It's not just a mess, it's actually dangerous. That's why it's our mission here to create this common language. A common language the same way as they have it in the music industry, a way to communicate seamlessly between engineers. If this is such an important thing, then why hasn't we solved it yet? Well, the industry have tried. So we have seen a couple of solutions out there. Here are 3 common answers. They're all clever, they're powerful, but they completely miss the point. AI models are only as good as the data they are fed. So if you feed them messy data, they will spit out messy data as well. Manual mapping is also something that we have seen, but it's slow, it's expensive, and it's error-prone. Vendor lock-in kills flexibility and innovation. So none of these really solve the root of the problem. We don't need a smarter tool here. We need a smarter system. So what if I told you that we actually already did solve it? We solved it many years ago. We solved it by something called reference destinations. It's a solution which is much more simple, much more elegant, and have been tried and tested throughout the years. The answer is so simple. Why hasn't it really been done before? Well, as the excitement for the digital world accelerated into the 21st century regarding software and digital models, the digital language kind of got left behind, and it got forgotten in the process. It turns out that reference designation or tags, they aren't just a label out there. They're actually keys. They are keys to unlock seamless communication between teams, instant traceability, and smarter automation and diagnostics. Reference designations today takes them from the concept all the way to retirement, from design to operation. We have made it our mission to create one tag, one truth, zero guesswork, one thread across the entire life cycle. You can actually say that reference destinations for us are like the Esperanto of engineering. They let mechanical speak to electrical, software talk to hardware. They let humans talk to machines. But how do we do it? But how do we know which tagging systems then to use? Be quiet. There are actually quite a few of them out there. Pretty much all legacy systems are either hard to learn or very complex, or they're impossible to scale and make work for big data. If we try to arrange the possible solutions out there of the reference destination systems by how hard they are to learn and how hard they are to scale for big complex data, we have taken some of the usual suspects, and it turns out that they're pretty much either hard to learn, and they're also pretty hard to scale for big amount of data. But if we now try to see what we have done with 81346, we made it our mission to make something here which is both very easy to learn and very easy to scale. So how does this work? In our group, we have stuck to some core principles. We want to keep and stick to a simple syntax, but it can handle unlimited complexity. We have made it our mission here to introduce proper classification framework with definitions. And we have also allowed multiple structures and viewpoints. Making something complicated, that's easy, but making something easy to approach, that is hard. But I want to say that from the working group with ISO IEC 81346, it has been worth it, because this standard is constantly expanding and constantly evolving. Yeah, and I think that was the fly into the next thing, where Henrik, he will take you a little bit more details regarding what it means to us, for us to build what we call a reference model.
Thank you, Philip. So thank you for that, Philip. So Philip has been introducing you to the idea about having a common language, and a language that is not just reserved for electrical engineers, but it's a common language that all engineers should learn to speak. And to support my colleague Philip, I would say it's not a problem making things complicated, but it's a very hard task to make things simple. And I think the way we have achieved that 81346 works, when you know one of the parts, we have made it in such a way that you know all the parts. And that's what I'm going to introduce to you. Maybe you have already discovered now, we're not going to give you a lecture around how 81346 actually works from a technical perspective. We are flying you around and sharing with you what we actually use it for ourselves. And that's some of the common things I would like to share with you in my part of your presentation now. That's called a reference model. So the premise for understanding what 81346 is about, there's like musicians play music, engineers are engineering systems. And that means, Arthur said it actually in his beginning, that the premise you need to understand and you need to buy in to understand 81346 is that we talk a lot about systems. And when we talk about systems, we talk about systems, and we repeat systems, the more the better. Let me give you 3 practical examples. Let's start in the high end. This is the Airbus A350-1000 on its maiden flight in France. And what we have done together with Airbus is that we have redefined the aircraft and the systems that it comprises of. You might think that they already have that, and the answer is yes, they already have a manual, they have an existing tagging system for their aircrafts, but that tagging system turned out not to be valid for digitalization efforts. And therefore, we introduced for Airbus, maybe if we convert the aircraft to systems that comprise of systems, and let's define them according to 81346, it will help a lot. So just to be practical, we have a lift system, which of course are the wings. We have a rudder system, which comprises the horizontal axis of the aircraft, etc., etc. So everything you see on the aircraft from now on is considered to be systems, made of systems, and we constantly use the word system. If you look at an apparatus like this one, this is a blood gas analyze device. It's actually originally a Danish one. Today it's owned by an American company. We use the same technique. So when we see apparatus when you see an apparatus in front of you, we think systems. It has a conveyor system for the analyze. It has a chassis system. It has a display system. It has a chassis system, etc., etc., etc. So a way of unlocking the clarity and a way of organizing the chaos that Philip introduced to you is that the first thing you do is literally that you take system glasses on. Everything you see from now on are defined as systems. Just for your own surprise, in fact, human beings are also considered to be systems. So in fact, you can look them up, and we actually have officially 11 systems. For example, we have a muscular system, skeletal system, cardiovascular system, nervous system, etc. I don't know if it's available in Finland, but at least in Denmark, when I go to the doctor, I'm pretty sure he has a skeletal system and a muscular system hanging on the wall. So I do suspect when I get sick, he's not interested in me, but he's inspecting one of my systems. Just think about it. But if you also think of it, a human being is extremely complicated and complex, and a way of organizing the first complexity is to organize it in systems, as you see in front of you. So the premise for understanding system and understanding 81346 and understanding anything you do in your daily life is considered to be a system. When we have done so and we have accepted the fact that everything is a system, that's a belief we need to take, then we would like to model it. And I need to spend a little time while introducing to you what a model is about. So allow me to take something very simple, namely a Lego model. So if I want to model an aircraft, in this case, I've used Lego Duplo and I've used 10 pieces of Lego Duplo bricks, I can create a model of an aircraft. Yes, I know it's a baby model. Yes, I know it's simple, but on the other hand, no one can question that this is a model. So models are extremely useful. And of course, the point is, if I want to model something more sophisticated, like the big Concorde, you can actually buy that as a Lego model toolkit. In this case, you have 2,083 pieces. At least that's what's written on the box when I bought it. And when you assemble it, you get a nice piece of model like this one. It actually gets so detailed so you can model seats and toilets inside. It's still a model, but it has the commonality that the more elements you add, the more details you get. So the more you add to a model, the more details you get. And I would like to repeat that when we talk about system modeling. So if we combine modeling with system thinking, then we would like to introduce to you what 81346 is in fact about, namely creating a reference model. And just to make sure that we are not talking about something that you don't know what is, I have made a little definition for you here. So in the context of this presentation, a reference model is an informative representation of an object, person, or system for reference purposes. Now, the little word reference is something that you have to remember, please, because we need to get back to it in a moment. But that little word reference is the big difference of what 81346 actually offers you. So please remember the little word reference from now on. So if we combine system thinking with reference and with model, what do we get then? Well, first of all, the same rule applies. So the more elements we get, the more details we can get, just like the big Lego thing. Then we need a syntax. Philip mentioned it in his presentation before, but we need a syntax so we can point at somewhere in the model and know what we are talking about. And finally, but not least, of course, the model is not made with Lego bricks, but it's made with system bricks. And these system bricks are defined by the IEC 81346 standard. That's for the first secret we would like to share with you, also to the many new beginners, that when you open 81346 and you look into the definitions and the terms, we use the word system everywhere we can get away with it. System, system, system. We repeat it constantly, and we think about systems every day here in our company. So a few words about how 81346 actually works without getting too detailed. But first of all, as Arthur was introducing to you in the beginning, it consists of increasingly a number of parts. We have part 1, which are the rules and the principles. We have a new fantastic part 8 coming up, which is about properties. When you work with digitalization, you want to work a lot with properties, length, weight, and stages like that. And to cut a long story short, we have managed to introduce what we call RDS properties, which is a very easy and simplified way of working with it. It's Part 8 painting, and I'm very proud and happy to say that Philip is the project manager of that project as well. Philip is very good at physics, and there's a lot of physics stuff in this way of handling properties. Part 2, which is all the basic stuff, you can see there's a triangle inside, and that triangle is actually a way of simplifying our way of communicating. I'll show that in a moment what that means. Then we have a nice range of industry parts. We have Part 10, which is anything related to power systems, any kind of energy you want to produce, whether it's wind turbines, nuclear power, coal, or solar. Same, is all handled by Part 10. And we see a lot of energy companies transferring towards Part 10 nowadays. Part 12 is about construction systems, when you build a house, and the latest news is we're going to expand it for to be infrastructure as well, which means roads and tunnels and stuff like that. Part 14 is about manufacturing systems, machinery that produces something, whether they produce milk or pack milk, or they produce cinnamon rolls, same story, or even produce aircraft. We use Part 14 for that. The new Part 20 is about vehicle systems. It originates from the job we have done together with Airbus for a range of years now, but we have expanded the idea, so we don't talk about systems in an aircraft, but we talk about systems of vehicles, which means that it fits for ships, it fits for cars and trucks, but also for aircrafts and helicopters and stuff like that. And then we have a new boy in town, so to speak. We have something called system processes, which means when you perform a process, if you want to describe how to build a road, or if you want to perform or describe how to make a process of shifting a filter or mounting something, we have created a new Part 50, which is about the processes that you can organize as well. So as you can see in front of you, the standard is growing, but the way that it's growing is that when you know how one part works, if you know how Part 2 works and Part 1 works together, when you get the idea, you can easily unlock the rest of them, just depending on what you want to do. And in daily life, we usually only work with Part 1, 2, and then we work, of course, with Part 8 in the sideline. But usually our clients is either a power system owner or a construction owner or manufacturing system owner or vehicles. So the whole idea is that we have parts related to your specific industry. Now, just to fly you in without getting too detailed about 81346, how it works. So in a nutshell, when we are asked to new beginners like half of you, how does it actually work? Well, first of all, the way to sort things that are complicated is that you need to break them down. So you have a system which is organized in subsystems and subsystems and subsystems so on, which is what this little figure represents. And finally, we also have the triangle. The triangle is a ready-made repository of systems you can pick from. And that means it's just like a box of Lego, to be honest. You open the box of Lego, and there you've got all the elements you can build from, and then you simply just model it by making a system breakdown. The standard has a very important way of making clarity, and that it uses something called aspect thinking. And aspects basically just means that you sort things in different kind of categories. The standard has 4, it actually has 5, but in this case, we show 4 different kind of aspects. We have the original one where we focus on the functionality, focus on locations, the variants called types, and we also have something called the product aspect, which is a way of modeling how things are physically made. Finally, but not least, the standard has introduced lately something called relations technique. That means that when you have organized these different kind of views, then you can start to say which function can I find in what product and where's the product installed, just for example, like this. And that is very useful because when you put all this together, then you can create the famous reference model that is in fact what 81346 is about. So 3 things in a nutshell: system breakdown with a repository, aspect thinking, and how things relate to each other. We know by heart that if you have not done this before, it will take you less than a day to learn the technique, especially if you download some of our free examples. It will make life more easy for you. Now, the triangle. So we have organized system thinking in what we call prime systems, technical systems, and component systems. And let me illustrate this with a box of Lego. So if we take this box of Lego and we unwrap it to system thinking, in prime systems, you will find stuff like vehicle storage systems, facility system, mobile extinguishing system. In technical systems, you will find predefined stuff like revolving door, gate system, cabinet system, staircase, etc. You can read for yourself. And at the bottom, you'll find all the bits and pieces that are made of: windows, doors, cables, pumps, etc., etc. And this is a repository that you pick from. So it's a box of Lego with 3 boxes of Lego inside. And with this one in hand, you can model anything. To be a little bit more realistic, if we go into part 10, in daily life, we call it RDS-PS, but it's part 10. Let me show you an example of a wind turbine. So this is a project we have done together with Vestas. So same philosophy: prime system, technical systems, and component systems. So in the prime system, in context of 81346 part 10, the wind turbine itself is in fact a system called a wind turbine generator system. Then we have high voltage transformer systems, main subsystem, generator system, gear system, etc. And at the bottom, you have sensor systems, fan systems, pump systems, etc., etc. So the same philosophy. And the whole idea is that if you want to make a model of a wind turbine, you simply pick from here and you put them together so you can create a model. When you created the model, then you need to refer to it. For that purpose, we need something called a syntax. The syntax is something that we are all familiar with, but let me show you a practical example of a syntax. My email address. So this is in fact the syntax we use every day. So it has a receiver, it has a separator sign, and it has a domain. That's pretty obvious. So this is a syntax that we are all used to. And likewise, 81346 also has a syntax. The syntax goes: we have a prefix, we have a class name, and we have a number. If you look at the prefix, we have the 4 aspects: functional aspect, product aspect, location aspect, and type aspect. And for historical reasons, in fact, it originates from 1971 and 74, I think it was. We use equal, we use minus, we use plus, and we use percentage sign, and that's just a way of communicating what aspect am I talking about. Now, regarding the class code, we have decided to make an easy, recognizable way of navigating in prime systems, technical system, and component systems. The fact is that prime system has a 1-letter code, technical systems has a 2-letter code, and component systems has a 3-letter codes. The only difficult thing is that these letter codes are not related. So it's just like looking at 3 different kind of color codes. So they don't have any kind of specific relation to each other. It's just 1, 2, 3, and that's it. The number is super easy. It's just 1, 2, 3, 4, 5, 6, 7. And up front here, I would like to say sometimes we see that numbers has a specific meaning. 100 series means that, and 200 series means that. And to be honest, up front, we never ever recommend doing that because it's very, very difficult to maintain. It's just a, sorry to say, stupid number. And with that in hand, just to give you an example, then we have a reference designation, and it looks like that. And sorry for the color confusion, but that is when you get the PowerPoint, which you will get later on. Then you can relate the blue stuff is the prefix, the orange stuff is the color-coded class, and the number is just the green one. And then we get a string like that, M1, MS1, ULN1, and the point is it doesn't really upfront tell you anything except that it's a structure. And I'll show you in a moment what it means, but that's actually by purpose because thereby we have the common language. So if you in Finland write this message to me, I can decode it no matter what language I'm speaking. You can even write it in Finnish to the next to it, and you can write thrust system, combustion engine system, motor block in Finnish. As long as you write that sentence, I can decode what you're actually trying to tell me as well. And that's what we mean talking a common language. So when you're new beginners, and I'm very happy to see that half of our audience today is actually new beginners to 81346. So if you want to start using 81346 and you have a need to organize your complexity, this is what we always recommend new beginners to start with: make a system breakdown model. Now that's more easy said than done, but let me give you a small hint to how it's actually done. So the way it works is that Philip showed this very nice complicated drawing before. This is a P&I diagram, and it's a quite heavy loaded diagram, I could say, without saying anything wrong. It's quite heavily loaded. I mean, Philip and I looking at each other, we think it's complicated. We call that in daily life explicit knowledge, which means that somebody has made this and trying to explain something to you. So we can get a lot of nice stuff out of that explicit knowledge. When Philip will take over, he will take you a more practical example of how we actually do it. But I can guarantee you that if you put on your system glasses, we can decode systems just looking at this drawing. That's the easy part. Now, the difficult part is something we call implicit knowledge, and that basically means what is inside the head of your engineers. We have seen that many times, that a lot of knowledge that you need to know takes time to learn when you're new to a company. And what we claim is that we can unlock this implicit knowledge in the head of people by mapping this to a reference model. So it usually is a very nice way also for scale-ups, and when you have companies which are growing fast, it's a very nice way of communicating implicit knowledge, because you can pair explicit knowledge with implicit knowledge, and you can store that in the reference model, and then it will look like this. So into the picture to the right, you see two different kind of breakdowns, but you can also see there are some small lines in between. And the lines in between are in fact how things relate to each other, the dependencies you have internally. And that is an official way of expressing dependencies, that you relate things to each other. And that means if you pair explicit knowledge with implicit knowledge with 81346 relation knowledge, then you have an 81346 reference model. And I'm still surprised from these many years working with it, how powerful it is to unlock the knowledge you have in organizations by making these kinds of models. It's a very nice way of working. It takes time, but it's definitely worth the effort. Now, let me show you in reality how it looks like. So if we take our little baby model from before, and we focus on the propulsion system, the thrust system, then it will look like this. So if we imagine that we made this little plane, a system breakdown could look like this. Thrust system is made out of traction system, engineering, fuel system, steering system, and combustion engine system. And the combustion engine system is made of another technical system, an oil filter system, pistons and stuff like that. And as you can see here, I can combine the different kind of technical systems and component systems and put them into each other the way I like. So there's no limit. There's not just 3 levels. There's no limit to the work breakdowns you can make. The trick, and what a lot of people actually don't see, is that the reference designations is an address. So if I write equal M1, that means that I'm referring to the thrust system. If I'm writing equal M1, equal MS1, I'm referring to the combustion engine system. And if I'm writing equal M1, equal MS1, ULN1 is more or less difficult to say. And I know up front it's difficult to handle. You're not supposed to read the codes by heart. We have tools for that. I'm in this case pointing at the motor block. So that is where the common language is about. The language you speak, the understanding is systems, but the way we use 81346 is to address to a certain point in the reference model. And that means if we have 2 silos, let's assume we have a mechanical engineering department and we have an electrical engineering department. As you know, these 2 different kinds of silos speak different languages, and that's okay. The price you have to pay is that we need to make sure that they talk about the same thing. And the way that is done is very simple. As long as they refer to the same thing in the reference model and they use the coding technique from 81346, they are talking about the same thing. This is what 81346 is about in a nutshell. Now, as I said in the beginning, I've been working with 81346 for 30 years, believe it or not, and it has been an integrated part of my life, and I still love it a lot. But I lost track, so I had to ask AI, what can I actually use 81346 for? I mean, Jesus Christ, I can use it for a lot. But so I had to ask AI specifically, please tell me what 81346 offers. And I got this funny response. Well, it said, by asking it said, well, first of all, you get reference designation, which means they are structured identifiers for systems, component, and assets. That's very nice. Thank you very much. That's in fact what 81346 offers. Then it gives you a system architecture model, a clear hierarchical representation of complex systems. I mean, I want a thing like that too. Then this little tricky thing, cross-domain consistency or unified naming and classification across electrical, mechanical, software, and civil domains, in daily life called a common language. Now, the 4th reply might surprise you a little bit because it actually came from my AI, but it says, it's a digital twin enabling. It's a foundational structure for interoperable digital representations. I was surprised and happy, but also totally agreed with the response from AI in this respect. And finally, but not least, improved lifecycle management, because as Philip was saying in the beginning, the whole idea, because 81346 is a life cycle stable thing you can refer to. So even AI seems to agree with us. That's very nice indeed. And with these words, I think it's time to go over to you, Philip.
Yes. Thank you so much. So that was, I think, a very good, a little bit technical deep dive into 81346, but also a very good perspective into what you can actually use it for. And again, why we're so passionate about it. But now we go into a little bit more, say, difficult stuff, because we want to do this, but how do we want to do that? How do we want transitions from 81346? So now I want to speak a little bit about how we go about implementing 81346 for larger organizations. And for that, I have a picture for you, because what do you feel when you see this? This pretty much is a representation of the challenge that people look into when they want to put a structure into something which is unorganized and kind of a mess here. We know that things must be done, but it seems like an impossible task, and things just keep on growing. You can imagine such a kitchen here where the mess just piles up because we don't really have the overview and the clarity about where to start. But as so many other things, there are a solution for it. So our recommendation is always kind of the same way as we want to clean up a messy kitchen. First of all, assess the situation, assess the legacy systems. What do we have out there? How messy is it? And how well does it already correspond to 81346, the direction that we want to set? Second of all, start small. Never try to clean up the whole kitchen at once, because then you'll never get done. Pick out a small section which works, where you can start cleaning out the space, and then slowly and steadily you can expand from that point onwards. And when you want to start small, then keep in mind that you have to prioritize the areas. Don't just pick a random thing. Fix a point where you can get some, say, easy return of investments, where you can show some value. And that's actually the heads up to the next question for today, because one of the first hurdles that many organizations have to go through is that how do you get this change through? How do you convince the rest of the company, or convince the leadership that we must invest in a way to align our documentation, to align our naming principle? So we want to ask you, when you look into your organization, and maybe especially for the people who are considering 81346, or considering to go to a more, you say, ordered, structured, uniform naming convention, which arguments do you think resonates most with leadership when adopting IES? Here we have picked three categories, but as Henrik was showing also through AI, there's actually a lot more key benefits that you can achieve here. But take the time for a moment to consider, do you think that your management will prioritize efficiency gains, for example, time and cost savings? Is it more focused on compliance and risk reduction with easier overview of the critical systems? Is it because maybe you want to look into digital integration and interoperability in the future? Or is it because that you want to be, say, immune for the standard or the subject matter experts which have this implicit knowledge? Do you want to catch that before it's too late? Bake that into a model so that we can easily share it with the rest of the people. I can see here that we have 2 people giving their best option. I hope that we can get a little bit more. We got 12 last time. It's okay to just pick the answer which also you just think which resonates most with you within your company. I want to give people a few minutes, and then I can also take a sip of water in the meantime.
Det doesn't come up on the screen. Kommer ikke op på skærmen. Okay, super.
All right, let's see. We got 7 people this time, 8 people now. The answers doesn't show up immediately, but when I push the button here, then we'll all see the answers at once. This is also a slightly more, you can say, difficult question because we have to consider the whole organization. But let's see what people answered here. So, yeah, and you can of course keep submitting the answers as well here. 2/3 of you said that is efficiency gains, so time and cost savings and things like that. And also it's 40% here actually more towards the digital integration and interoperability. These are 2 of the you can say big things. Digital integration and interoperability especially is what many larger organizations are looking into 81346 to achieve, because they need a digital language across their different domains. But we also know that, of course, when we have to sell it internally, we are looking on return of investment, how easy will it be to gain back those time in those time invested. And you can say the easier the implementation and the better we collaborate and also get this going, the fewer resources is also going to cost, and the quicker you can get this return of investment. And that's where that's what I'm going to speak a little about now. So, where to begin? As I said in the beginning here, we have quite a lot of experience, and also Henrik showed some of our portfolio with a vast majority of different organizations. And we kind of always have the same approach to it, the same main principles. It's very important that we create some standard documents where we have the rules for application. And this means that we bake in, you can say, the syntax and the rules for how to apply 81346 in our organizations with our examples and with our system. That's way it's quicker to visualize and show to the rest of the organization. The other key thing that we have to keep in mind is that we are not alone. We are actually a big organization, and there are many stakeholders who are affected one way or another by this reference designation systems. So we need to identify our stakeholders and keep them updated and keep them engaged throughout the project. The third thing is that in line with the detail that we have to start small with a small area in the beginning, we want to keep that as a pilot system. Pilot and then iterate. Don't make one big bang. Make small steps, small drafts, present it to the stakeholders, get feedback, and then build from there. When we develop the rules for application, we focus very much in our company that we are speaking to people who are practical. And that means that we do, for example, manuals in an A3 format with lots of visual examples that really dig into both how the documentation looks like, but also the visual representation between this is how the system architecture looks like. It's much easier to show how things done instead of describing how things are done. Of course, the descriptions and the rules are also relevant, but you are much more inclined to get people on board when you have nice visual examples. And that's the next thing. Henrik, he also showed you you could say quite complex diagram with a lot of explicit knowledge. We like to take those diagrams and really condense them into system thinking. That means that any kind of complicated diagram that you have out there, for example, PFDs or PNIDs or even electrical diagrams, we've made it our mission that we can systemize them. We can designate the areas which functions are we speaking about. We can color code them. And suddenly these, you can say, quite complex technical diagrams, they get much more visual and much more easy to explain to people. The nice thing is that whatever we have on the visual diagrams here corresponds one-to-one with the system architecture model that we're also building based on the same 81346 principles. With these nice visual examples in hand, you are much more inclined to get people on board because you can describe and show what we're actually doing. One of the quite important things is that we need to engage our stakeholders. And here I could ask you together with all of you, have you actually considered in your organization, who are your main key stakeholders? And also, who should you involve and on which stage? Successful implementation is about keeping the information flow going and listening to the feedback. So here are some of the stakeholders that we normally engage with when we go on to clients. We make sure that we speak to operation and maintenance because these are the technical people who are going to own and read the reference designations out there in the field. Engineering and technical teams who are sitting maybe more on the design point of view, quite early on, they are also adopting a reference designation system to keep track of the design and the components throughout the life cycle. So these are some of the people to have at the back of your mind. And last thing here, which we really want to underline, is that we want to give the ownership of people of the RDS system to an RDS owner. So we designate an RDS owner within the organization who are like the governor of the RDS manual, who knows about the RDS systems and know how to expand upon the different kinds of aspects and all the rules that 81346 gives to the different kinds of companies. Without an RDS owner, then sort of the rules and the examples can point to all kinds of different directions. But if you have the ownership, then you know who to go to ask more questions or to elaborate more on the system architecture. The last thing here is that we want to emphasize we need to pilot and iterate. So that means when we pilot and iterate things, there are a few very positive things that we get out of it. If we just deliver first a draft, it is an option to get some early involvement from our stakeholders. It's an option to get some early feedback and keep people in the loop to see how the feedback actually developed and is integrated into the models and into the examples. We also emphasize very much that we need to define, you can say, the core rules about how to apply basic 81346. And then people have all sorts of good application ideas. Well, we can also designate our data. We can also designate our documents. That's all well and good. That's called pull within an organization. But keep the scope limited in the beginning so you don't overwhelm yourself with all kinds of different use cases. So make it work one step at a time. The question that we often get, and why this also might seem overwhelming, is that people already have a legacy system out there. They have some sort of RDS system which has worked quite well for some time, but it isn't really suitable for a more modern age, so to speak. We want to emphasize that you keep your old documentation, you keep the old system, but you map to the relevant areas in the new system. This will, for the most part, be a digital transformation, and this means you don't have to go into the physical world, look into all your current equipment and start to retag all the items, all the pumps, all the bells, and so on. No, again, assess which equipment do we need to put into the new digital model, and only designate things into the digital world. You don't have to designate the physical stuff with the new text. You just need to make the mapping between these two different languages. So, to summarize here, you need to keep a few things in mind. 4 things here. Keep the scope tight. One system or asset class is enough to surface most issues. This isn't about solving everything at once. It's about revealing the patterns, the edge cases, and the naming conflicts that matter. Start small, but go deep. Then you need to visualize the result for your colleagues and your managers. Use diagrams and designations, hierarchies to make outcomes tangible. Don't just talk about structure. Show the structure. When stakeholders see how systems relate, how functions map, and how identities align, they will engage with you. Visual clarity builds consensus. Also, document rigorously. Treat the pilot as a proof of concept. Capture what worked, what didn't, and why. This isn't just a test, it's the foundation for scalability in the future. Clear evidence builds trust across departments and disciplines. And lastly, engage with your operators and your stakeholders early. Their feedback often reveals practical gaps that engineers overlook. They know what's used, what's ignored, and what breaks. Bring them in before the structure is locked. Their insight makes the systems useful, not just compliant. So these are our recommendations for things to keep in mind when you want to expand upon the RDS system and really implement it in your organization. From our point of view, we just want to say that there is plenty of material and help in supporting you in this journey. We have a site called 81346.com, and here you will find some free material that gives you some basic examples about how 81346 could look like. But you're also more than welcome to reach out to us through the email or through our website. Yeah, that's basically it, I think.
Yeah. A few more words from me, perhaps.
Yeah.
So we are, thank you, Philip, so much. We are hitting the end of our presentation. One more thing, when you go to the 81346.com, you can see there's a tab called software. And there are 2 things. There is a free app. So since you have your smartphone in your hands, both for Google and for Apple, when you go to their stores and you simply search for 81346, there's a free app. If you think it's lousy and it sucks and it's not good, please remember that it's free and it was difficult to make. So we made it because we couldn't help it. We know that people love it anyway, so please bear with us if it's not super duper, but at least it's free. And this is, of course, how you look up the coding principles. So you search for term motor, you search for term this and that, and the app will give you the coding principles, so you don't have to think about that. Furthermore, we also created our own tool, which can integrate with other tools where you can create the structures, you can create the relations. But today we're not going to present that. This was more or less an appetizer just to show that there's plenty of stuff. Finally, but not least, if you go to the, let's see if I can have it here. If you go to YouTube on the little figure next to get started, we are happy to see there are quite a lot of people, including ourselves, who have made different kind of YouTube training videos. So we have a very good friend in Norway who has done his own training videos. We have some things coming from Germany, and we have our own YouTube channel where Philip has made 7 videos that will introduce you to the basic technique of 81346. Made in chunks of 5 or 6 minutes, so you can look at that while you have a cup of coffee anyway. So we hope that you will join us in believing in the common language, believing in system thinking, and believing in the common language for engineers called 81346. And with these words, I think it's time to say thank you from us, and then it's time for a lot of questions you may have for us. We've done match ones here. Yeah.
Thank you, Philip and Henrik. And Now it's time to answer possible questions. And
So please use the chat for that. So do you ask if there will be a recording? Yes, and of course the presentation we've just been giving, we would like to send that to, I will send that to you, Hannah, and then you can distribute it to the participants as well. So you will get the presentation in PDF format later on as well.
Yeah, we'll put it also to Sesco FI.
All right.
I have one question.
Yes.
What I learned today is the new role, RDS manager. So can you tell me about more if organization wants to try out RDS system in their work or production, and what are the requirements to become a RDS manager? Who should have that role?
Well, we actually have not thought about calling it RDS manager. We call it an RDS. I think RDS manager. That sounds nicer, actually. The idea is that there already is people within an organization who are, you can say, governing the system structures and the overviews, whether that right now lies in PDM systems or the PLM systems. You have designated, you can say, experts already. But you also need subject matter experts who knows how the 81346 system works and it looks like. So when people start adopting it, they know who to, you say, come to and ask, how are we going to build about this new structure? Where can I find the manual, and which pages of the manual should I need to look at, for example, as an electrical engineer or as a process engineers. Usually, that's what we see in larger organizations.
Thank you.
Then we have two other questions. Let's start the first from when is the new version of 81346 Part 2 expected to come out, and what kind of changes are expected? Well, Philip, you were a part of the group, so you must be the right guy.
I'll keep answering here.
Yeah.
We are fastly developing 81346 Part 2 with quite some good updates. We expect it to be released in the final stage in early 2026. That means Q1 2026. And there's been quite a few, you can say, good new updates to the standard. So first and foremost, the major new things in 81346 Part 2 is that before we had only, you can say, classified spaces. That means the 3-letter codes for basic meeting rooms, toilets, kitchens, corridors, technical rooms, and stuff like that. Now we have built on top of that. So that means that we follow the same triangle principle, that the same way as you have prime systems with 1-letter codes, technical systems with 2-letter codes, and component systems with 3-letter codes. It's the same philosophy now with locations. So now we have something called construction complexes at the top, which is designated with 1-letter codes. That could be hospitals or theme parks or power plants areas. Then we have what we call construction entities. That will normally be considered buildings, but it can also be a parking area, fuel station, something like that. And then you can break that even further down into the basic 3-letter codes, also called spaces. So now these principles are now contained within 81346 Part 2 as general principles throughout the different industries. Furthermore, we have also expanded upon the component table. So now we have more mechanical parts into it. And we're also better at actually designating furniture. So furniture within rooms and how you want to, for example, put furniture into a car, like car seats are actually pieces of furniture. We can actually go to that level and even designate that as well. So lots of good stuff happening.
Thank you, Philip. So let's take the next question in row. Are there any good examples of infrastructure? I mean, bridges, roads, earthworks, etc. So if I start with that, I think Philip will take over because Philip is the big project manager today. It's nice to see. But part 12 originally was created for buildings. And when we finalized it, I allowed myself to say we because I was a part of it. We were quite aware that we didn't have time to include infrastructure like bridges and stuff like that. But it seems that there's a big wish for it. So first of all, I would say that it's a new part. The revision of part 12 will take that into account. In our company, we have the pleasure of working with at least two companies that work with infrastructure, and one of them is Nye Veier in Norway, which is a subset of the road authorities in Norway. And they are very keen, especially on part 50. So one thing is around the having the roads and the stuff, but it seems especially part 50 about processes, things you need to do to construct a road or to make safety right. That seems to be a very interesting add-on for them as well. So one thing is the road itself, but I think Philip talking about Nye Veier and their way of handling systematic breakdown of their way of doing processes is a very nice add-on that people like a lot. And since you are the project manager again for part 12, maybe a few more words about part 12 from your side regarding infrastructure.
Yeah, so as Henrik said, part 12 was originally developed to take care of buildings. So one of those that we are into right now, going into details with how do we construct foundations and walls and slab systems and so on and so forth. But what we have really seen a pull again from the industries are, all right, that's buildings, but how do we handle bridges, as you said? How do we handle tunnels, roads, and so on? We have made it now our mission to say part 12 is very good at buildings, but we need to take it one step further. So we need to update part 12 to make sure that it can address the infrastructure classes and the structural systems, which, for example, buildings and so bridges, tunnels, and so on consist of on the basic component level, but also on a system level, like technical systems and prime systems. So we have initiated that work, and my best guess is that it will take between 1 and 2 years before we can say we have a new part 12, which is even better, still backwards compatible. So we want to make sure that all currently defined codes in part 12, they still work, but maybe there will be some updates soon and new additions, some new codes which goes further into details with railroads, for example, further into details with roads and so on. Yeah.
And meanwhile, have a look at part 50. Part 50 is coming out now.
We are in the CDB stage, so.
But it's available, so if you contact CESCO, you can get the preliminary version of it as well for the other parts. If you can't wait to see the new part 2, it's in the final disk state already, so there will be no technical changes. So if you can't wait to see it, I'm sure that Arto and Henna will be happy to supply that one for you. Arto and Henna, we didn't discuss this, but I assume that you are willing to share that kind of new stuff with your friends up there anyway.
Of course.
And
Yeah. So you just contact them and then you get it, but it's not too long. So next question, what is the minimum financial budget to apply this, for example, to electrical device manufacturing process to get some benefits? Ooh, that's a tough question. Well, usually when we are used as moderators to introduce 81346, there needs to be some kind of driving factor. That's why it was interesting to see in our quotation that especially digitalization efforts is a very nice way to invest in 81346. So, of course, when it comes to return on investments and stuff like that, then the answer would be as well, it depends on how much money you lose today, where the effort is. And that might be a little bit tough, but we have some key figures that will help you in justifying that. Besides that, I would say that from an electrical point of view, there's no alternative. It's as easy as that. There is no alternative. And as I can see in the next question pending, you are already using it, but things are updating. So sooner or later, you need to update. We, in fact, did that project for TeacherPack 2 years ago, where they realized that they were stuck to some very old way of thinking in 81346 back from very old days, but it didn't really fit their new development and it wasn't response to what they were doing. So the little bit long answer is, to be honest, I don't know. but you need a project to hook it up on, and then you need to realize what do you lose today and if it should be worth the benefit, unless somebody forces you to do it before you know it. We have some other clients in the green industry sector, and they are discussing a lot when is the big jump towards Part 10, the new for power systems going on, because there's an old version called PP, and there seems to be still some asset management who wants that one instead, but it seems like the industry is all ready to go to the new part. So we discussed with the two of the suppliers for the green energy. It's a question of whether you want to wait until somebody demands it from you or you want to be ready. And they more or less say, we like the new version so much better, so let's move. So just to say, there are other elements than the financial stuff. So that was to Tero. I hope that explains it, at least to a certain degree. All right, last question as far as I can see. Are there any references of example of existing industrial? No, sorry, that was not the one. It was to Mikko. And then Tero asked, what if current asset structure is a combination of functional, location, and product aspects because of the historic reasons? Should we rearrange systems into 3 different aspects now? That's a clever question. We like that one. And you're right, that's for historical reasons. We used to, and I say to allow used to because I did that myself, to glue together these things. And in my world, it becomes one tag. So if you have that functionality of that product installed in that location, it's just one tag. So, and then you're stuck. Then you're really stuck. So you need an excuse or a product to unlock that because it's also knowledge. So you could unlock it to the degree that if you separate them into 3 different kind of tracks, the functional breakdown, the product breakdown, and the location breakdown is a new world opening for you. So, and you can and then you can still keep what you already have because changing history is very difficult. We haven't talked about this today, but for those of you who still hang on, we often get the question, oh, we already have an existing numbering system and we can't change it for historical reasons. And we say, we know, we think you should keep it as it is, but we also expect you to make a new reference model, and then that reference model can refer to from the old stuff. So that means you keep what you have, but you create something new instead of replacing it. That's typical what happens very well. And as I also said in my presentation, the existing tag number system represents explicit knowledge that you can reuse, so it's not lost. So last question, are there any references or examples of existing industrial plants or power plants moving from, for example, KKS to 81346, that's more or less PS? That must be you, Philip, because you made the transition with the examples as well.
Yeah. So we are quite proud to engage with, you can say, multiple actual larger organizations who are really looking into 81346. But they have one key concept in mind, and that is that they don't actually want to go, you can say, to all the legacy, all the currently existing equipment and the components and so on, and retag everything. That's not actually what they are looking into. What they are looking into is saying our old tagging system doesn't really fit into the model, into the modern digital world. So we need this 81346 asset management structure here to have a common model which we can expand upon also into the future, which we can communicate together with our suppliers and our PDM systems and ERP systems. So yes, we actually see quite a lot of big players, big industries moving towards 81346, are integrated into their new projects. But I want to emphasize, it's not like they're going out into the currently existing power plants and started with a demo and started relabeling everything. I want to highlight here that, for example, if you are within the wind power sector, there is a working group called the Team Wind, Technical Information Management for the wind sector. They have made guidelines for how we actually can break down and make a common system architecture for wind turbines. So the big players within wind energy, they are agreeing on how to create common models, common reference models, which are applying the RDS 81346 principles to keep these systems architecture in check and having the same reference throughout the life cycle of these wind turbines here. So I hope that answered the question.
Yeah, if I should add something, I think our questioner asks if there are any examples. So if you go to 81346.com, And if you click on free material, you can download an example of how a wind farm, including the transition lines and stuff like that, could be made. And correct me if I'm wrong, but the transition examples going from RDS PP to PS is also there.
Yeah. So as Henrik was saying, we on the free tab or free material tab, we have made one of the free materials is a superheated steam power plant, where we have the previous, you can say, KKS RDS PP codes, and we simply have made that transitions into the RDS PS codes instead. And here there's a quite clear like one-to-one mapping. So what is a sensor over in RDS PP also is a sensor over here as RDS PS. But RDS PS is of course much more manageable, and we can expand that into multiple different areas and multiple aspects as well. So go to 81346, and here you will find some more examples.
Yeah. I think the next question is actually, do you feel it's part 8? So you are
I'm the lucky one, but I'm also very lucky to be project lead on some of this big initiative. So Arthur here writes, the future part 8 will contain properties, right? Yes, it will. Will different products and functions aspects have their own separated characteristic sets of properties? Well, that's a quite good question. The way that we now have made this property framework is that we have put all properties that we have seen into the world. That means weight, electric voltage, density, thermodynamic exchanges, all kinds of stuff. We've taken that sort of pool of all these words, and then we've categorized them. We've actually categorized them in like main groups in thermodynamics, mechanics, and stuff like that. So each property have got its own class codes, its own, you say, identifier about what we are speaking about. And then we have made it like Lego bricks. So that means whatever we are designating, it could be a space, it could be this meeting room. I can associate this room that I'm in with a RDS code from 81346 part 2, for example. And then I can associate it with, for example, what I call it, volume. Yeah. So I can point to the volume of the room itself. Or if I have a product, then I can maybe identify the torque needed to assemble these two pieces of screws. I simply point to the screw with 81346 and put the code for torque at the end of it. Then I have the torque of the screw. And the same thing with functionalities. So it's like Lego bricks. You are free to put together these things as you want in order to express exactly what it is that you need.
So to support Philip, what we did, and allow ourselves to read it, is that we wanted to follow the track of 81346 of simplicity. And that's a pretty crazy task when you deal with properties, because they tend to grow and grow and grow and grow, and people try to predict it. So what the project group has done, and I would like to give the full credit to the project group because I was not a part of it myself. But it took a clever guy like Philip to sit down. So we have extracted all the physical dimensions from ISO 8000 series and put that into the standard to its designated. But the clear answer is, when you ask if different products and functions will have their own characteristics, the answer is no. It works exactly the same way that you have separated views, and then you go to the box of property bricks, and then you can build anything on that you like to. There's no limit. On the other hand, the thing we have created is extremely simple. So, for example, we talk about a length, but we don't talk whether it's an inner length or outer length, or diameter, or whatever. A length is a length, and then the user has to define, all right, but I would use the length as diameter, or I would like to use the length as width, and stuff like that. And you need to define that yourself, because thereby we have managed to simplify it. We have seen efforts to make other kind of properties sets in other kind of initiatives, and they tend to grow completely wild because people try to predict all kind of properties, and we know up front that will not be a possible thing. So I think, Philip, last time we talked about it yesterday, there are around how many properties in total?
I think it's around 800, something like that.
In total, and that's it. It might sound like a lot, but the way that it's organized is that's all you need. And we have seen 10,000 of properties going on in other places. I think the point is that we are very precise around it. And one more thing, and then we have time for any more questions. One of the things which we are very proud around, I could say, in the international working groups, is that everything, all systems, all spaces, all technical systems, prime systems, component systems, spaces, construction entities, all properties, all processes, all of them has a definition. Which means that if we compare it with other initiatives, people tend to list door, window, stuff like that. But the way that 81346 has become a common language that works across industries and works across borders and works for Finnish and Danish and stuff like that, is that all the things we have created is based on definitions. And that means we have a library of set of terms that we use, that we agree upon. So one of the really cool stuff around the job, which is done in part 8, is that all properties has a razor-sharp definition, even bounded in physics. And I have not seen that myself before, so this is really world-class. And also taking the 81346 hat on today, and since it's an ISO joint working group we are working on, it also belongs to you in Finland. I'm very happy to see that we have managed to make properties which are bounded to physical stuff and based on hardcore agreed definitions. That is really world class. Yeah, so that was the last question in the chat. Any more questions you may think of? We are happy here. Otherwise, I think that it's time to hand back the microphone to you, Arto, maybe to wrap up for today.
Okay, thank you. Thank you, Philip and Henrik, for the presentation and the answering the questions from the audience. And on my behalf, thank you for joining our webinar today, and special thanks to our presentators, and have a nice weekend. And Henna will provide a recording, and could we also have a presentation on as PDF to be linked in our website,
Yes.
so that can be used as a reference for further consideration.
We will send it to you immediately after this presentation, after this session is over. Thank you from us as well.
Thank you very much for listening and providing your questions.
Yeah. Okay.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.